The purpose of this design is to mitigate the lunar plume surface interaction on the lunar south pole. This solution falls under the category of reduction of erosion and ejecta during descent, landing. Our solution consists of a carbon nanotube sheet which is laid on the designated landing area. A set of robots will anchor the sheet in place during landing and takeoff of the rocket. The CNT sheet, which serves as the landing platform, allows for landing and takeoff operations without disturbing the lunar soil. This prevents damage from these operations. The CNT sheet will also protect it with NASA's dust mitigation technique to repel lunar dust and keep the CNT sheet clean. Based on the size of the lander, we determine the size of the CNT sheet carpeting. The size calculations are given in the engineering analysis section in the following pages. A set of lunar robots initially levels the designated landing site. The robots we are proposing as part of the solution to spread CNT sheet are general-purpose robots that NASA might already be using to build some lunar structures as part of the Artemis exploration program. More discussion on robots is presented in the engineering analysis section. Then, a CNT sheet is rolled out and anchored firmly at all corners by these robots before the lander takes its landing trajectory from lunar orbit. To avoid lunar dust collection resulting from natural lunar environmental processes, dust storms, etc., the CNT sheet is activated with NASA's dust mitigation technique developed by Dr. Carlos Cali. At the time of landing, robots maintain stability of CNT sheet and adjust its spread as necessary based on trajectory parameters. Once the landing is completed, the CNT sheet continues to serve as a floor to the lunar craft until the eventual takeoff. With the NASA's dust mitigation technique, the CNT sheet continues to be clear of lunar dust and be ready for eventual takeoff. Once the landing takeoff cycle is completed, the CNT sheet can be rolled up and kept away for future reuse. The main risk is that the CNT sheet must be spread out and anchored firmly to ensure a stable landing and takeoff. This requires some ground leveling and anchoring work done by the robots. The robots can be entrusted with this work as similar work is required with all other assets that are not part of the PSI solution. The main innovation is arriving at the best combination of CNT and T and other polymers to produce a fabric type of product that can serve as a platform for landing and takeoff operations. The most important assumption is to have access to robots that can spread and anchor the carpet on the lunar surface.